I love this saying, don't judge a book by its cover. Everybody is told this when they're in kindergarten. You have to keep an open mind and understand, learn about people, learn about situations before you make any snap decisions. I also add, don't judge a garden by its surface. Now the left-hand garden, everybody says, oh, what a beautiful garden. It's been tilled, it's clear of weeds, that soil is nice and fluffy, it's ready for me to put my seeds in, then I can mulch over it, and I'm going to have a beautiful, productive garden. And then you look at the garden, our garden, on the right, and you say, what is that horrible mess? And what am I going to do about it? Hopefully, by the end of this talk, you're going to go home and plant the bag of seeds you have, because you're going to want that garden on your right. And I'm going to explain some of the benefits that will have for you. First of all, we got to do basics. What is soil? We've got minerals, organic matter, air, and water. Minerals is 45%. That basically comes from the parent material, the rocks, and that varies by region. You're stuck with it. There's nothing you can do about it short of digging it up and taking it out. The organic matter, even though it's only 5%, is something you have direct control over and is the most important component of your soil. Now, when I'm talking about organic matter, most people think humus, they think leaf clippings, they think compost, manure. Expand that definition to include living microorganisms, macroorganisms, and fungi, and that would include bacteria, protozoa, all the living creatures in your soil. I would like you guys here to tell me what is healthy soil. If someone says, what is healthy soil? What are you going to say? What do you look for?
25 earthworms per square foot.
Okay. How many would have said that? Is that kind of your standard definition of healthy soil? What else?
Grows anything.
Grows anything? Okay. What else? What's it look like?
Good color, dark.
Dark color.
I think a nitrogen, phosphorus.
Okay.
Not laced with pesticides, herbicides, other sides.
Okay, so I've seen dark, which is physical. I've heard chemical, which is whether you have nutrients and whether you have chemicals. And I've heard earthworm, so I've heard biological. And you cheated because you know this stuff. Well, we've covered everything, almost. We've got biological properties, physical, chemical. And really, really generally, that means presence of organic matter, good soil aggregation. Okay, that doesn't mean rock-hard clumps, and it doesn't mean dusty powder. And then the proper balance of nutrients, nitrogen, NPK. Now, these numbers over here, 75, 20, and 5. We have a field day every year at our farm, and I asked George Derringer, who is an NRCS scientist, I said, George, if I had to quantify between biological, physical, and chemical properties, what relative importance does each of those characteristics have to good soil health? Take a guess at what he said is the most important one. Biological. How many people here do soil tests to test their nutrients in their soil? Okay, we've got a couple. If biological is so important, what do you do to test biological? So, well, put it under a microscope. You cheated again because you know this stuff. But he said, believe it or not, the soil testing that you do has only 5% relative importance to the soil health. It's a great indicator of the productivity of your garden, but that does not mean healthy soil. 75% of the importance of your soil rests in the biological characteristics. And this 20% over here for soil aggregation is totally dependent on the biological properties. Now, everybody should write this down, and you should go to it every day. NRCS, USDA.gov. The NRCS is the Natural Resources Conservation Service, and they have sheets. If you go to their soil health assessment, they will give you sheets. There are probably 20 to 25 soil health characteristics, biological, chemical, and physical, that they list there. On these sheets, it's a front and a back, very easy to read, quick to read. It tells you aggregate stability. It tells you about aggregate stability, what's good for your garden, what's bad for your garden, and what you can do inexpensively to improve that. 2 things you're going to come up with on every soil quality indicator worksheet. Do not till your garden, ever, if you don't have to, and use cover crops. So now we're going to focus on that 75% the organic matter. Why is it important, and how can we impact it during our gardening? One thing you have to remember is your ground where you garden is not just a place for your plants to put roots. It is a community in and of itself. There is more living biomass under the ground than there is on top of the ground. And you have to feed it, you have to take care of it if you're going to have healthy soil. Now, I did have a video in here of what earthworms do, but I couldn't get it to work, so I skipped it, but I'll kind of display it, I'll tell you about it. We took a video, well, we got a video of 3 worms in a cornfield. And these worms were taking an entire corn leaf, and they were pulling it underground. The entire corn leaf, they pull it underground. They take it down, they digest it, they eat it, they excrete, and leave all those nutrients underground, where your roots need it. You see the surface castings, but those worms are doing a ton of work for you underground. So we've looked at the worm port. I like to call those my labor force. You've got the food web community under there with the microorganisms, macroorganisms. Now let's take a look at how that impacts the plant. This is a plant root tip. And you see this little membrane-like thing here. That area inside that is called the rhizosphere. That surrounds every root tip of every plant. I don't care if it's a weed, your garden plant, a tree, anything that has root tips will have a rhizosphere. Now, the rhizosphere, all these little things here are bacteria and protozoa that live only in the rhizosphere. Did you know that 30 to 60% of the growth in young plants is strictly to send that growth to the ground, to the roots, because the plant purposely sloughs off root tip cells to feed the microorganisms, which in turn release chemicals that break down inorganic fertilizers and materials in the soil into a form that your plant can then use. For every gram of rhizosphere soil, so that's any dirt that's immediately surrounding this little pocket, there are over 1 trillion cells of microbes and vertebrate numbers are doubled compared to the soil that's just outside here. So it's critical that you have roots in the soil, and the more roots you can take, the better. I don't care if they're weeds. Every root supplies the bacteria and the microbes in the soil with food, and it's critical. Soil bacteria and mycorrhizal fungi, that's what makes the nutrients available to your plants. The plant can't do it on its own. So every time you fertilize in your garden, you're putting on an inorganic form of fertilizer. Maybe 10 to 20% of that is made available to your plants. Maybe. And it only happens because you've got critters in your plant that are doing it for you. So this is all very interesting, but so what? Well, those bacteria and those protozoa, they're all eating, they're all living, they're all excreting, and one of the things they excrete is called glomalin, which forms a glue. That glue binds together soil particles to give you good, healthy soil structure. Now, here's a picture of good, healthy soil structure. Air, water can get through these pores, so when it rains, it doesn't run off, it goes down in your soil. When your roots grow, roots do not burrow. Roots do not break through dirt. Roots go through available holes in the dirt. So if you've got a pore from a worm, if you've got a pore from a decaying plant root, that's where your roots are going to grow. What does that lead to? If you've got good soil structure, again, because of the bacteria, you're going to have good water holding capacity. Now, our prairies, our native prairies, 100 years ago, had about 7 to 10% organic matter in the soil. They could hold over 7 inches of rain before we had any runoff. That's a 100-year storm, and it would not run off. Our typical agricultural soil has 1 to 1.5% organic material. That's in your garden too. I'm not just talking large-scale agriculture. Now I'm going to do a demonstration, and I don't know, I'll try to talk loud.